Solve system of simultaneous ordinary differential equations. This is our problem that we have to solve, and it is find the values of y and z at x is equal to 3, and these two simultaneous ordinary differential equations are given, that is f1 is equal to dy over dx is equal to z, and f2 is equal to dz over dx is equal to minus y, and we have to solve these two equations with the help of Runge-Kutta method. And the initial conditions are given: x is equal to 0, y is equal to 2, and z is equal to 1, and step size h is also mentioned. Theory. Now we see the theory behind this Runge-Kutta method that we are using in this coding. Suppose you are given two simultaneous ordinary differential equations, as you see on the screen. Dy over dx is equal to f1 and dz over dx is equal to f2, and these two functions f1 and f2 are functions of x, y, z, and initial conditions are x0, y0, and z0. And what we have to do, we have to find the values of y and z at x is equal to x1 is given in this problem. The first thing that we do is to decide the step size h for the iterations. You can decide any step size, and in this particular problem you have been already given the step size. Then we find the number of iterations, and the formula for this is given on the screen. Now the method applied. First we calculate the values of two parameters k1 and L1, and the formula is given. Next step, to find the values of next two parameters k2 and L2, and the formula is given on the screen. In the third step we find the values of k3 and L3. This is the fourth step, in which we find the values of k4 and L4. Finally, we will use the values of k1, k2, k3 and k4 and L1, L2, L3 and L4 in this formula, and we will get the value of y1 and z1. These are the Scilab codes. First we define two functions for our two ordinary differential equations. Now you see the initial values, and how we find the step size. This is the iteration that we do, and here we use for loop. This is the final result, as you can see on the screen.